learning about security doesn't need to be scary.
If you want to ship code securely with confidence, check out the URL below and challenge yourself with thousands of challenges in 29 coding frameworks. Let the games begin.
So, hope everyone had a good coffee break. We're all caffeinated, ready to learn. Awesome. So next up, yeah, there we go. So next up we've got Max Feldman. So he's from Slack. So I'd like to welcome him up. Can we have a round of applause for Max, please? So he's going to talk about his bulletproof shoes and protecting from accidental token leaks.
Yeah.
Leave it to you, mate.
Cool. Thank you. Hello, everyone. Yeah, and this is Bulletproof shoes. I am not currently wearing bulletproof shoes. I'm wearing Vans. These would not protect me from bullets. So I'm Max Feldman. I work at Slack on our product security team. My Twitter handle is Mrs. Bufferworths. I check that occasionally. If you want to get in touch, I'll also be around the rest of the day. If you have follow-up questions, I work on a handful of things at Slack. I run the bug bounty, I do feature reviews, a lot of the general AppSec things that folks do. How many people here work on insecurity as opposed to like development? How many people work more in development? Okay, cool, nice, a good breakdown. So I'm going to talk a little bit about the introduction, overview of Slack. Many of you may have used it before. The problem we faced, our token nuker, how we implemented a technical solution to help people not shoot themselves in the foot, the iterations we've made on that, the advancements, and some lessons learned, and then we'll have some time for Q&A. So Slack. How many people have heard of Slack? Cool. How many use it? Okay, so some of this will be familiar, some might not be. I'm going to talk just a little bit about what it is, the platform, Slack apps in particular, because that's what we're most interested in for this talk, and talk a bit about our developer ecosystem and how the tokens for these apps can be abused and why we want to prevent them from being abused. So what is it? Slack, at its most basic, is a richly featured conversation platform, interweaving conversations, apps, files, etc. It's like at its simplest, you can use it for communication in the workplace. In more advanced ways, you can like integrate a bunch of your workflows. You can use various applications, cloud services, etc. It'll connect your team's conversations with all of your tools, keep them kind of in one place. And so the platform takes high frequency, low effort work that happens a lot and brings it into a more automated workflow where your team can see it. So kind of bringing everything into one place. So what is a Slack app? It's a key piece of the functionality and usefulness of Slack. So if you've used Slack, who has used an app in Slack? Cool. So examples of this might be Giphy, which is for sending GIFs to your coworkers, your teammates, whoever else is in that channel. It might be GitHub. It might be running your CI/CD pipeline. It might be doing 2FA. It might be security tooling. It could be expense approvals. It could be procurement, HR things. It ranges from chatting your coworkers to performing complex tasks for the business. So they bring the functionality of other sites and services into Slack. Sometimes they're simple. Sometimes they're complicated. The purpose of them varies widely. And there are a lot of major SaaS providers who have Slack apps, but also a lot of smaller ones, people building custom integrations, etc. So there are over 600,000 developers on apps. So that's not apps themselves. That's people who have created an app within Slack and worked on it. And some of these end up in our app directory where there are more than 1,800 apps. So these are things that you can install. So this is something in our app directory. You, a Slack user, can go install it. It starts working with your workspace. A lot of the people developing apps have developed custom integrations and things that are internal. So they're not like the Google Drive applications. They're the one-off bot built to integrate with something internal. Who's built a custom integration for Slack? Cool. Or does anyone work at a company that offers a Slack app? That's cool. Yeah, some places do, some don't. A lot of places will do internal things. But that means there are over 500,000 people who have worked at some point on a Slack app, which could potentially involve tokens, credentials, et cetera, and things that have security implications for the users of those workspaces. So what is the general architecture of these apps? We have the Slack client, so this is your phone, your browser, your desktop. This communicates with the Slack server, which runs in AWS, and then that communicates with an app server. So apps live outside of Slack. We don't run the code of these apps. This contrasts something like Salesforce, for example, where you have App Exchange apps. Those might be running on your Salesforce instance. Or a mobile app that's running native code on a client. The code and the functionality of these apps live outside of Slack. So sometimes it's AWS, sometimes it's another cloud provider. But these, we need to connect these. So Slack can send events over, or you can use the web API to reach Slack. And this communication means that some kind of authorization and authentication is required. So how do we make this API work? We use tokens, OAuth 2.0, as the framework for this authorization. And this is how we issue access tokens. So if you're creating an app or if you're installing an app, it's going to go through the OAuth flow. So if you... who's seen an OAuth flow before? OK. If you haven't, or if you have just a refresher, a nice thing about OAuth is if you want to give someone, like a third-party app, access to your data, or to your infrastructure, not your infrastructure, your data, to resources, you don't need to give your username and password over. You don't need to hand over credentials or your keys to the kingdom. You can grant a limited scope to an app. So there's an OAuth dance. You have an authorization request, a grant, authorization grant, an access token, and eventually the application is using an authorization token to access data owned by the resource owner. And in this case, the resource owner is a Slack user or something accessing Slack, and the application is a third-party app. So there's a token that is used to access Slack data. When you install an app, you approve scopes for the installation. So these are scopes of varying access. In general, we recommend following the principle of least privilege. If you're making an app, if you're releasing one, only request scopes that you need. But there are a lot of scopes. So simpler ones are confirming an identity, getting an email address, and these range to reading all of the channels, reading channel history, accessing all data, impersonating users, posting messages into channels, et cetera. So there's a very broad range of scopes. They give a lot of power to applications to give functionality to workflows, to the things you need to do. So while we recommend using the minimal scopes necessary, sometimes an app needs a lot of scopes. Sometimes it needs to read messages and make to-do list actions out of them, or file a bug. And so if anyone has possession of this token, that means they get whatever scopes are associated with it. So some examples of these, and you may have seen these if you've fiddled around with Slack before, if you've built an app. We've got the XOXP token, which is a user token. It's a user granting a bot resources, and it acts as that user. Bot token, XOXB, it's a token that creates a new user that's a bot user. And the naming convention for this is because these are the prefixes of those strings. So if you build an app, you'll see XOXB dash blah, 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 blah. Or if you search GitHub, for example, which will bring us to the problem we're facing. They're not the only tokens. You also have like XOXS, XOXO. Through varying points, there are, in time, we've used various prefixes. So what is the problem? Things do get leaked. How do they get leaked? Well, let's dive into that a little bit more. So we have, to recap, there are 600,000 plus people who are making apps. And even more people just using Slack who have these apps installed in their workspaces. Lots of people are working together, collaborating in interesting ways, but accidents happen. Tokens can get leaked. Things can get pasted into version control systems online. You may have done this before. You may have seen this happen before. You may have seen vulnerabilities reported because a token was exposed on GitHub, for example. And that's a problem. So if we do a quick search on GitHub for XOXP, and just a reminder, this is, sorry, there's a bug if you can't see the little bug. There are tens of thousands of tokens on GitHub, and this is just XOXP. So this is a bit dated. There are actually more now. If you go and search XOXP on GitHub, you'll see even more than this. If you search XOXB, you'll also see thousands. If you search XOXO, you'll see thousands, but then some of those might be more like if people comment in their code XOXO because they're, I don't know, trying to convey hugs and kisses to other developers in their organization. You have a lot of these, like thousands and thousands of results. So that means a casual attacker can just go search on GitHub and grab a token. So that was a valid token, and a person anyone on the internet could just go and grab that. So what can they do with that? It depends on the token scope. So if the scope includes channels read, channels write, channels history, you can get everything. You can dump an entire Slack workspace from the perspective of a user. So if I created an app, I put my token on GitHub, someone takes that token, they can read all the messages I've sent and all the channels that I'm in. It can just be lifted, and all that data can be exfiltrated very quickly. There are other scopes that are dangerous as well. There are administrative scopes. There are scopes where the token could be used to make changes to the workspace, to not only post to channels, but to change memberships, to invite new members, to do very damaging things. And so we've seen all the types of tokens. So some of these are legacy, or there are legacy types of tokens, or API endpoints. We've seen tokens of all types on GitHub. We've tried to be very thorough on making sure that we delete all of them, which we'll get into. But so what information could be in your Slack workspace? What could be the downside of this? Why would someone care if someone can see all the GIFs you've sent, all the memes you've sent, all the bad things you've said about your coworkers behind their backs? There is much more sensitive data potentially in your Slack than just that. There could be corporate secrets. There could be maybe your company's filing for IPO. Maybe your company has financial secrets. Maybe you have credentials in there, which we advise against, but maybe they're there. Links to Google Drive files or things where the security relies on knowing that link. All of that information could be in Slack, important files, private messages, etc. Could also be a means of impersonating a user, delivering malware if you are trying to do a phishing attack. So there's a lot that is in there. And people do make mistakes. Who has ever Googled this before? You also don't need to answer if you have Googled this before, but we can see over time that the searches for git remove history have gone up. You might realize once you've made a commit that something was taken, that there have been instances of people committing AWS tokens, for example, and within minutes, more instances, EC2 instances are spun up and mining Bitcoin. So depending on the tokens you have, you might notice immediately that it's been taken. You might not. But more and more, this with the increase in prevalence of like cloud storage and cloud version control systems, the presence of secrets and credentials on those systems, and as they're able to be accessed by the public internet, has increased and become more dangerous. So this is not hard data, but you in your company or in your side projects, you may have seen this before. And so what do we want to do? We want to stop people from shooting themselves in the foot. So Slack tokens can be very powerful, and they need to be very powerful if we want to have a highly functional app and something that's very useful for folks. So we recommend limiting scopes as much as possible, but sometimes an app does need to read all of the data. Sometimes it's an e-discovery or a DLP app, and it needs all of this information there. So getting shot in the foot sucks. If you leak your token, it sucks. If you are at risk of having all of your company's data taken by malicious people on the internet before you can even stop them, it sucks. So that brings us to the token nuker. So what is this? It's an application that we built to find tokens and to revoke them. So I'm going to talk a little bit about the implementation of this, the architecture, some additional features we've added, and then some lessons learned. So as we saw, there are tokens on GitHub, tokens on the public internet. So we want to nuke them. We want to keep our developers safe. We want to support folks in the event that they've made a mistake. We don't want people to have to face the drama and the trouble of having your workspace breached. And we want to create environments that are safe by default so that if someone accidentally pushes a token to their repo, it's a learning lesson and not a company-ending catastrophe. So how do we do it with automation? So we know that token leaks can be searched easily. It's just a matter of time until someone gets this information. So who has seen, there are websites that post credentials or suspected passwords, et cetera, as they get committed to GitHub? Who's seen a website like that before? Cool. Have you built a web? Just seen. Okay, they exist. If you're curious, you can see the tokens that are getting posted on the internet second by second, minute by minute. But those sites aren't the only things monitoring that. There are actual attackers just running a server, scraping GitHub, et cetera, waiting to find that AWS credential that lets them mine Bitcoin, waiting to find that Slack credential that lets them view a company's chats and maybe just deliver malware into the company, depending on the scope of the token. So we can't manually do this. Obviously, we can't just search GitHub and go token by token and check, like, oh, is this valid? So we want to be quick, and so we built the token scraper / token nuker. So the infrastructure of this is we've got GitHub up in the cloud. We've got our token nuker, which is running in our infrastructure, but not like as part of the Slack web app. And we have the Slack web app. So the web app has a validation and revocation endpoint for tokens. So we search GitHub. We scrape GitHub, find everything that matches a regex, and then we pull it into our token nuker. We check, have we seen it before? If we haven't, we check Slack. Was it valid? If it was valid, then we revoke it. We leave a note in our database so that we can check, like, oh, when was this revoked? Or was it revoked? Or was it ever valid? Was it invalid? This helps us, generate some of the graphs that you'll see later in this presentation. But so if we match a regex, we check if it's valid, we revoke it. So we also post to a Slack channel. So this is our security tokens burn channel, which is just message after message after message after message saying, revoked this token, emailed this person, or emailed these people, and here is the location of it. So we track all this information for our own purposes and also to help the customers a bit. Because this channel is also used by our CE team, like customer experience, customer support. If people see that a token has stopped working, they will reach out and say, hey, my app broke. Hey, my integration broke. And we'll talk a little bit about how we try and preempt this and save some time. But this channel is public so that people can use it for support purposes. So there are a handful of challenges with this model, not all of them technical. The technical aspect of it is actually not too difficult, like scraping GitHub, finding a regex, matching a regex, not the hardest problem in the world. One of the harder problems is the customer engagement aspect of it. So if we just broke things for people, people would not be happy. They would probably blame Slack. If your integration works one day and it stops working the next day, you're not going to think, oh, I was at risk of being attacked and benevolent Slack came and saved me. You'll think Slack broke. Why does this API not work? You might spend some time debugging and trying to figure stuff out. And then you'll email Slack and say, hey, this broke. We don't want to overwhelm our support agents with this. And we have information that we can give to people. We know where this was found. We know the owners of these teams and who created these tokens. So we can inform them. We also want to be concerned with the rate limit. So if you just scrape GitHub, scrape GitHub, scrape GitHub, you'll eventually hit rate limits. So we needed to do some backing off of this. We'll also talk about an awesome feature that GitHub released that is a beta feature, but super handy and helps us be even faster with this. We also might introduce a new type of token. We do this every so often. So it's very important for ProdSec to stay in tune with developer teams, the platform teams, as they're creating new tokens. Because if we're not aware of those, then we have new tokens getting pushed to GitHub that are creating sources of vulnerability if people are leaking them and we're not stopping them. So customer engagement, as I said, we can't just say, we can't say nothing. We also can't just say, hey, we revoked your token. We want to give useful information. We want this to be a learning experience, and we want our CE team to have a pleasant time helping people and possibly not have CE get involved. If we can just send an email that conveys all of this information, hopefully we can save everyone some time. So we send a sort of long email, but it does have a link to our help center. It does say what the team was. It gives some information about what has happened. Because if you get an email that just says, warning, you leaked a token, blah, 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 it can be frightening. It can be concerning. If you're working somewhere small that doesn't have a security team, maybe you just wanted to get something up and running quickly. Like, this could kick off an incident that you're not super equipped for or would just be very stressful, and we don't want that to happen. So we try and give a good amount of information in the email without being too long to read. So I talked a bit about the evolution of the token nuker. So one of the coolest things on the next slide is GitHub's feature. But a couple other things we did to improve. We moved to a proper instance. So at first, this was just running on a dev box of one of the people on our team because he wrote it over a weekend and just put it somewhere that worked. But we wanted it to be a little more resilient and to have like a database that doesn't crash and can like boot up in case of emergencies. We don't want to have a case where we re-email people and say, hey, we nuked your token, and then we crash and then we do it again or something. We also have added new tokens that we've had, and we worked with GitHub, of which there are a couple people here at this conference, and I don't know if they're in this room right now, but some folks from GitHub around. We worked with them on a beta feature they have, which is token scanning. So GitHub tells us, so as opposed to before where we had to scrape GitHub, GitHub shoots us a post message like we exposed an API. GitHub sends a message to that API saying, hey, we found something that matched your regex. It was found here, and lets us do what we will with that. So the architecture change there is now, in addition to searching, we receive events from GitHub. So we have a shared secret between the two of us. GitHub sends a request with the signature. We verify the signature to make sure it's actually GitHub sending us information. And then we perform the rest of the steps as usual. But we also note the source of this token that we found. So maybe we found it by searching, but now more often than not, it's from GitHub's notification. And their notification is fast. You don't have to worry about rate limiting when you're getting informed by the people watching. So this greatly reduces the amount of time between a token being pushed and the time we find it. In the worst case, like maybe we had to back off for rate limiting, and there's a matter of even minutes is enough for something bad to happen. So we want to be instant. We want to be nuking things as fast as possible. So beating anyone else who's scraping GitHub, because those are how the malicious actors are working. Another iteration we made was the webhook nuker. So who's seen a Slack webhook before? These are the easiest way to post data into a channel. There are integrations that use these. You can write one yourself. Super quick, low effort way to get data from somewhere through the internet and into Slack. So what could go wrong here? It's not quite as bad as a token, depending on the scope, but you can impersonate a bot app. You could send a phishing message or phishing link, malicious links, spam, and abuse. So something we also don't want to deal with, and we don't want our customers to deal with. So a quick search on GitHub shows 52,000 plus results that match this. A quick caveat here, anecdotally, a lot of these have been test webhooks, so it's like hooks /services /gibberish because people do know better than to post these, but we still want to nuke them. And so we rolled this out last month. I'll show a little bit of data about this. We don't have as conclusive of data, but it's all right. So some feedback and lessons learned. We have our nuke token history, and so this is by month for the last, since 2016. It goes up into January of 2019, so missing a couple months. But we have a kind of steady flow of tokens nuked here. about 400 per month, a couple spikes here and there. But a really interesting thing is you can see here where GitHub rolled out their beta feature and we started supporting it. The number of tokens that we found by the search method, which is scraping GitHub, dipped off to almost nothing, and the number of tokens found and reported through GitHub's push notifications to us is practically 100%. So there are a couple little differences here and there, but for the most part, all of the tokens we nuke now are because of GitHub reporting them to us. And so what this means is GitHub is also the first reporter. So we have not stopped running our search. We continued to scrape as we rolled out GitHub support. And that just means GitHub beats us to the punch. So we're still searching things, but GitHub in 99% of cases is informing us faster than we could find it, which also indicates that we're getting the information as fast as possible. So other people, malicious actors who are searching GitHub, et cetera, they're not going to be beating GitHub to inform us about these tokens. And so we are deleting them before they can be abused. And so we see, like, once we rolled out GitHub, 97.5% of the tokens found and nuked, and this is just for tokens, not webhooks. I'll talk about that in a sec, but 97.5% were found by GitHub search, and only a small fraction were found by our own search, by our scraping. Another interesting point of data is the valid versus invalid tokens based on our regular expressions. So valid here means something that when we encountered it could have been abused and was still valid. So about 20% of the tokens were not valid, which means they were already, like, either already invalidated or maybe they were a dummy value. But 80% of those were active and prone to abuse. Little interesting thing here is tokens revoked as grouped by team. So you see, like, for the most part, most teams, if they did have a token revoked, only had one revoked. There was one team that had 19, so that means they committed 19 separate valid tokens to GitHub. We didn't look much more into this. We think it was a test team, but for the most part, once one mistake happens, it doesn't happen again. Couple teams are outliers there, but that's kind of a good indication that our communication is helpful, or that at least people realize, like, not to do that again, because we don't see that happening again for another team. So that's great. Nuked webhook history, it's worth calling out this time scale and number scale is different than the previous chart. This is just for the last month. So we're seeing about 40 webhooks per day nuked. This is not counting an initial push where we went and, like, prior to launching the active scanning, we nuked everything we found on GitHub in one fell swoop. That is not included in this. It would have skewed this data. So on a regular day, about 40 webhooks. And here's the breakdown by our scraping and searching versus GitHub's webhook pushing to us. In a couple spikes is where we still found some stuff by searching, but for the most part, it's still GitHub informing us about these issues, which means we're as fast as we can possibly be to nuke them. Invalid versus revoked sits at about 50-50, so some of these webhooks matched the regex but weren't valid or had been rotated. A possible reason for this, if you've seen our the webhook interface, is you can quickly regenerate a webhook. So sometimes people do that just because they want a new one. We have some external feedback that we've received. So one customer quote was, just wanted to thank you. That's a nice service. I like it. That's pretty solid. If you're building a service that stops people's stuff from working and then sends an email saying how they had a potential security issue, to get positive feedback on that is pretty nice. It would be very easy to receive feedback saying, like, why did you break my stuff? I know what I'm doing. Why are you why do you do this without my permission, etc. But to get some good feedback is always nice. Everyone likes good feedback. This originally started with a conversation with a Detectify researcher who pointed out the state of tokens on GitHub and the state of webhooks. So we've had some back and forth there. And we coordinated for both tokens and webhooks there. So there are some Slack app features that are also worth calling out. If you are ever building something, we do have IP whitelisting for internal integrations, so you can lock down a Slack token based on an IP range. So if you know where it's running and you know it's only going to be in a certain IP range, then you can lock it down to that. We do have admin-approved apps, so there's a little bit more admin controls about who can install apps in your workspace. We use that at Slack, so I can't just go create in the Slack workspace an app that does whatever I want. It needs to go through an approval process. There's also the audit logs API. And a friendly reminder, please don't put secrets on public repos. So or in any repos, don't put them in version control. There are better ways of storing secrets. You can use vault, config files, environment variables, git ignore. They're just like a lot of things that will prevent these from ending up in Git in the first place, because these will also stay in your Git history. Even if you delete the file, even if you make an update, that token is there in the history. If that is the case, you can use the repo cleaner, which is a handy thing for getting rid of all history, making sure you're good before you push something to the internet. Linting rules are also handy, so you can, with Slack, lint for XOX star or something. And so, like I said, if people are conveying hugs and kisses in their code, then maybe that's not great. But for XOXP, XOXB, etc., it'll still work. And if you have a platform, if you're not an app developer, but you're working somewhere that does have tokens or that has people writing integrations for your platform, this is something you can also do. So you can look for your own tokens, you can revoke them, you can help developers on your platform be safer. And there are other people using that GitHub beta feature. So I think AWS is one of them. I think Google and Microsoft. It's published online if you search like GitHub token scanning. And there's probably room for more platforms. Don't quote me on that. I don't work for GitHub. But if you work at a place that has a platform, it's something to be aware of, to be cognizant of, and to really consider as a way to protect your users and stop them from shooting themselves in the foot. So yeah, with that, we'll have some time for Q&A. And I do real quick want to say we're hiring. We do have a Melbourne office. We have a security team. We have, security team is mostly San Francisco, but there are tech people out in Melbourne. And there's also a meetup next week that I will not be at, but other people from Slack will be at. You can find more about that at Slack community. That's a developer meetup. So if you develop Slack apps, that could be a good place to get some advice or meet other people interested in that. So yeah, with that, we can do... what's a good slide to keep it on? We can do Q&A, I think. Do we have time?
We have plenty of time.
Great.
Fantastic. All right, let's give it to Max, everyone. So before we jump into the questions, so something like those community events are really, really good things to be a part of. So if you are looking for work or you just want to get involved in things, I was literally chatting to a young girl outside here earlier this morning, and she said, hey, I don't know where to get started. So going along to some of those types of things is a really, really good thing to do. So if you are around, come along. There's monthly OWASP meetings as well, so get involved in those things as well. But without taking too much further away from yourself, are there any questions? Great. There's one just there. Oh, no, I'll do it.
Stand. Yes. Hey, thanks. So I imagine this could be a really useful tool for like cert teams, because this could be, say, an indicator of something a lot worse happening. So, it's one thing for a dev to post an API key somewhere. It's another thing for, say, a developer to paste an entire internal repo on, say, GitHub if it's not supposed to be public at all, that sort of thing. Do you guys have any plans to maybe extend this to create your own webhook feature, to reach out to, say, a customer that would expose an API to say, hey, this was posted, maybe you should alert on this and do an incident because there could be a lot worse stuff here?
So currently, no. That's a good question and a good point. Currently, no. We are kind of aware of this, in the background of all of our thoughts and our concerns about customers, like how can we inform people from data we find. Right now, it's just the emails and the alerts, but it is on our minds, like how we can convey to a team or to like the security contact on a team that like, hey, we've seen this information that seems to be like your Slack token, or perhaps an app that was breached or hacked or something and affected you. It's on our mind, but we don't have something concrete for it. Yeah.
Is it possible to unnuke a token? Like, could I DOS a whole bunch of apps just by posting thousands of strings that could be tokens?
It's not possible to unnuke. The DOS attacks, it depends. Like, both us and GitHub have a decent amount of resources, so you'd like. I don't know for sure how it would affect GitHub, and they would be kind of the first processors of this because they're looking at both what gets committed to a public repo, and every time a private repo becomes public, that's when they run this, the regex matching. It depends on the resources they have available. As far as, so for us, I don't know what amount of tokens we would have to hit because we do have the caching, so we don't actually go through without, like we don't hit the Slack web app from our service unless, well, first we hit it to validate the token, and that's a very fast process, and then we don't do anything else after that. So to have the next logic where you would have like a lot of valid tokens being nuked, you would first have to generate all of those tokens, and then the generation would hit the Slack rate limits. So like there could be an amount of data where that might happen, but it's the generation of valid tokens wouldn't be fast enough in the first place, I think. Let me think. If you did it like very slowly over time and then did one giant commit, then the first party affected would be GitHub before us. And we have kind of decent recovery infrastructure for the tool because it's fairly simple. So if it does get taken offline, we boot back up.
I'm not trying to DOS you guys. I'm trying to DOS all the apps whose tokens I'm hitting.
Oh, okay. So, but they're. Oh, right. Okay, sorry. So if you want to DOS those apps because so if you had their tokens in the first place, there's worse stuff you can do, basically. So if you had access to the valid token of someone else, you could do bad things to them, but like if it were me and I stole a Slack token from someone, I would go and try and get all of the data out of the Slack instance, and you would have to get that token from them in the first place, and that would be the more difficult task. So if you did have a bunch of valid tokens, you could do malicious actions to a lot of folks, but the invalid tokens, there's nothing you can do with them. So like the tokens that are currently on GitHub, they're just there, so you can't take those and use them for anything. They're a remnant at this point. And if you had the valid tokens, you would presumably do other attacks. Like you could attack their Slack instance and possibly take it down if you had like admin permissions, but you couldn't do that at scale. And at that point, you're doing more like targeted attacks of a specific workspace. Does that answer the question? Or
I'll chat you after.
Okay.
Were there any other questions? There's one just down the front here.
Hey.
There's one before you, mate.
So when I saw the title of this talk was about protecting Slack tokens that are stored elsewhere. And I thought we were going to talk about tokens for other services that get put in Slack and revoking them. That seems to be like a really big problem in Slack workspaces. People seem to think that like Slack is a good way to send private keys or whatever. Is that something that's on the roadmap, or not the roadmap, but the radar of like Slack security?
Definitely. So our like number one piece of advice for that is don't do that. Don't put the private keys, passwords, etc. in Slack. But as you said, people do that. The way to prevent that now is through, we have DLP apps, and they can match for, you can install that. So there's not, Slack has the APIs available for DLP providers to do this. So you could use a DLP app to look for passwords or certain strings, credit card numbers, social security, whatever the Australian equivalent is of social security. And there's no equivalent. Okay. But sensitive information, but it's not, it's a part of the Slack platform and another app that you would use. So it's, we're aware of it, but it's one of those features that is best handled by the DLP kind of professional apps.
One over here.
Yeah.
Hey, sorry, this might be a little unfair to ask you, but maybe the GitHub people might jump in. There are a bunch of tools out there, third-party tools that people use in their DevSecOps pipeline that pick up if you are accidentally committing tokens, creds, whatever, to repos, and stop you before you actually commit. I can't help but wonder why GitHub are sending all this stuff to you or AWS or whatever when they could just stop it in the first place.
Good question. I think, well, okay, this is going to be very speculative, and I apologize if I'm wrong, GitHub folks, but GitHub, like, as a source of open information, so they could stop a commit, they could stop things from coming in, but then they would have to be kind of policing all of the, not even policing, just like protecting kind of arbitrary content. And so I think the sending of tokens to us is kind of above and beyond. Like, it's a really great thing for a cloud provider and host to do, but it would get very tricky if they would also still have to validate the token, because like you could conceivably have an example where the token is invalid, or you have a comment that mentions a token. There could be cases where you do want an invalid token or something that matches the regular expression or a webhook regular expression. So it could cause unforeseen consequences, and also it would kind of put the onus then on GitHub or the other cloud version control hosts to be looking for all the types of tokens and then add more and more, and like adding more compute power and resources to regexes, and like integrating with more and more token providers. And I think it's like maybe they're working on this, and some folks from GitHub are around, but I think it's a lot of the value of GitHub is it's whatever the code you're working on is up there, and you use other tools to make sure that it's up to par. And this is kind of like it's a really good thing and a really helpful thing that GitHub's doing as a courtesy to Slack, to our customers, to other users of GitHub. But it could be really tricky to go further than that, I think. That's my guess.
Thank you for that.
Yeah.
Great question too, mate. Were there any other questions in the audience? Raise your hand. Oh, Frenchie. Looking forward to this one.
I apologize in advance to Max. It's a reply to the question about detecting keys. This is a complete hack and is much more simple than any DLP apps. But set your Slack alias to RSA begin private key, AWS _secret _key, and if anyone shares them in a public channel, you get pinged. It's a hack, but it works.
That's smart, yeah. I mean, so you can also run, like, you could build a Slack bot as well that does equivalent features, like that keeps searching. Because we have an API for searching, we have an API for channels history. So, like, the end result would be you're re-implementing another DLP app, and that's a smart, hacky way to do it. Another more complete, still hacky way to do it is to run through all of your chat logs and match regular expressions for private keys, for things that have entropy and could be a password. But it's at a certain point you're building DLP, and it might be easier to just pay for that. But you can still do it. You can definitely do that, and that's clever. Yeah,
that is clever. No, he's shaking his head
I wouldn't
no.
rely. To be clear, don't rely on as a means of keeping secrets out of your Slack. Like there are definitely more full ways, but if that's happening a lot, I also think it's like, as someone on a ProdSec team, I think part of that can come down to the security team and like the work and the process that they do with the rest of the team. So we use Flashpaper, which is an open source thing that we run internally, but it allows like sharing of secrets. They're valid one time only. You go to the link, you can see whatever data is there, and then it's never accessible again, and it's a cryptographically randomly generated URL. That's not super difficult to run. It doesn't require much storage because it's short. It only has a 24-hour TTL anyway. There are other tools that are better for secret sharing and can be integrated with Slack, but I think if you're on a security team, then you have then you can help other people better understand why that's not a good idea, and then propose alternatives. So that's not a technical solution. That's kind of a how do you interface and socialize best practices with the rest of your organization.
Cool. Awesome. Thank you. So I think we might call it there for the questions, because we've got to rejig the stage around and get some chairs up, comfy chairs. I'll throw them outside. They look very nice. But if we can give Max a massive round of applause. That was a fantastic presentation.
Thanks, everyone.
Cool.
Thank you.
Alrighty, so, and can we also just give a massive shout out to our sponsors up there on the board as well. Thank you, sponsors. So we're going to set up the chairs. We're going to set up a thing called Slido, so you can kind of ask some questions. We're just going to try to project it up on the AV unit so you can see all the questions that are coming up. So one thing I'd like to remind you, because we're going to be projecting basically unsanitized data, if you could just kindly, revert to the code of conduct and just don't be a jerk about it. Thank you.